channel Euclid Mathematics. We have started lecture series on GATE previous year question paper. Within that, I already explained plenty of the videos on my channel, which is based on linear algebra, calculus of variation, real analysis, group theory, ring theory, and so many other subjects. All are necessary to our GATE exam. So if you wanted to see this video, you may check it into my playlist. So now in my today's video, I'm going to explain to you one of the question from GATE previous year question paper, which is based on a linear algebra. So let's get started on today's lecture. First of all, I'm going to explain to you all the question, then we'll move for the detailed understanding of solution. Question, we have given two statements, okay? Two statements are given, and we have to tell here that which one of the statement is correct, okay? So we have to find out which one of the statement is correct. So statement P, it says that the matrix is given 2 by 2. So consider the matrix 0, 5, 0, 0, 5, 0, 7, okay? The matrix is given in our question, has infinitely many LU, that means lower triangular matrix, and U means upper triangular matrix, okay? And their factorization, that means lower factorization, upper factorization. So LU factorization is given, L is lower triangular and U is upper triangular, okay? A lower triangular means a diagonal entry is 1, okay? Each diagonal entry 1, and upper triangular also given U as, okay? So here lower triangular means below diagonal element non-zero, and diagonal element is need to be 1, and upper diagonal element need to be a 0, okay? So how can we write lower triangular matrix? Lower triangular means diagonal element 1. You may write any n by n matrix, okay? And below diagonal element non-zero, that means A non-zero and other above diagonal 0, okay? This is lower triangular matrix, okay? So, and upper triangular, if you want upper triangular, then how can we write upper triangular? Upper triangular can be written as below diagonal 0, diagonal 1, and upper above diagonal non-zero, okay? So A need to be a non-zero here. Here and here A need to be a non-zero. So this is lower triangular, this is upper triangular, okay? And these two matrix, lower and upper triangular. So here in our option second, we have given Q, the matrix 0, 0, 2, 5 has no lower no LU factorization, where L is a lower triangular with each diagonal entry 1 and U is upper triangular, okay? So I hope you all have understood the meaning for lower and upper triangular, okay? Then we have to find out whether which one of the statement is correct. Statement P is correct, or Q is correct, or both is correct, or both is false, okay? Now let's find out. We first of all find the lower and upper triangular, and then we'll move for the statement P and Q. So in our statement P, we have given, now let's consider some matrix as A, which is equal to 0, 5, 0, 7, okay? 0, 5, 0, 7. This is the matrix given in our question. And now we have to consider the matrix EL as a lower triangular matrix. You may consider any matrix over here, but it need to be in this format, okay? Okay, this format is needed, lower and upper triangular matrix. So here I consider lower triangular as a diagonal 1 and lower diagonal non-zero, upper diagonal 0. And upper triangular I consider BDC, okay? So below diagonal element 0, okay? So this is lower triangular and upper triangular matrix. So what we have to do? We have to check A has infinitely many LU factorization. So can it possible A has infinitely many LU factorization? So for that we have to check A has, that means A has LU factorization. It is already given that, okay? A has LU factorization, but is it infinitely many or finitely many? We don't know, okay? So that means A has LU factorization, but we have to check whether it is infinitely many or not finitely many, okay? So now check it out whether it is infinitely many or not, okay? So A can be written as here 0, 5, 0, 7. This is the value for A. That means A has LU decomposition, okay? So that's why I written this way. L can be written as, here I taken 1, 0, A, 1, okay? This is A, and U can be written as B, C, 0, D, okay? You may take any matrix, okay? It need to satisfy LU property, okay? Lower decomposition, upper decomposition. This property need to be satisfied, okay? Now here we can see A, which is equal to LU. Now we have to check whether this A, which is equal to LU, has infinitely many LU decomposition or finitely many LU decomposition, okay, or factorization. So here we can say that if the value for A, we get the unique value B and C and D. So if the value for A, B, C, D, the value for A, B, C, D, which is a unique, that means we will get the single value for A, B, C, D. Then we say that LU factorization is a unique. Okay, unique means it is having unique value for each and every variable over here. Okay, that means we say that is a unique. It is a finitely many LU decomposition. Okay, or unique decomposition. But if any one of the value like A, B, C, D, which runs more than n times values, okay, so if the value for A can be possible 1, 2, 3 and so on, okay, and infinitely many value for A, infinitely many value for B, C and D, okay, if this is possible, if that this ABCD is having infinitely many value, then we say that our given LU factorization has infinitely many LU for factorization, okay, given matrix has infinitely many LU factorization. Now let's check out what is the value possible for this A and B, okay, so 0, 5, 0, 7, keep as it is 0, 5, 0, 7, okay. Now the multiplication for these two matrix, it become A in 1 into B plus 0 into 0. So first element will get the this into this plus this into this, which is a B, this into this plus this into this, which is a C, this into this plus this into this, BC, this into this plus this into this, AC plus D, okay. So I got the four values in our matrix BC, BC and AC plus D, okay. Now compare their corresponding values for BC, because whenever we want the values for some constant in our matrix, we compare their corresponding elements, okay. So the corresponding element for B is a 0. So I got the B is a 0, okay. So unique value for B, C again 5, C which is equal to 5, is yes it is hold, unique value for C, BC which is equal to 0, BC which is equal to 0. But here we can see I am having value for B is 0, okay, already having value for B is a 0. But what is the possible value for C that will get the BC 0? Now tell me, what is the possible value for C that will get the BC 0? Okay, so B is already 0 here, okay, B is already 0 here. But what about for C? We can take C as 1, 2, 3, 4, 5, 6 and infinitely many value we can take as C here, okay. How many value possible for C? Infinitely many value possible for C, because B is a 0 now. That's why we'll get the BC always 0 for any value of a C, okay. So this condition hold for C has infinitely many value, okay. Now we can see that we will get the infinitely many LU decomposition, LU factorization because of the value of a C. That means the value of a C we can substitute infinitely many values in our LU decomposition. So if value for C is infinitely many, then we can write this matrix infinitely many times, okay. This one is the infinitely many times. If this LU decomposition is infinitely many times we can write, then we say that this is the matrix A which has a infinitely many LU factorization, okay. This matrix has infinitely many LU factorization because C can be written as infinitely many ways, okay. So similarly you may guess by using AC plus D is equal to 0. So AC plus D which is equal to 0. So if I'm having B which is a 0, C is a 5, C is a 5 given, okay. Now what is the value for A? Is there any value for A? No, we didn't got the value for A here still, okay. So value for A which is depend on the remaining value. Value for D, what is the value for D? So again value for D it is depend on this one, okay, which is equal to 0. So there are infinitely many choices that we can substitute over here, then we'll get their addition 0, okay. So our first option, it says that so A has infinitely many LU factorization, which is a true, okay. So which is absolutely true option, okay. I hope you all have understood. It is very easier. Now let's figure it out for option number second, which is for Q. Can we say that Q has infinitely many LU factorization? Okay, you may take any matrix, okay. So it's better to take already we have the LU decomposition. So that means we have to show that a Q matrix has infinitely many LU factorization, or finitely many LU factorization has no LU factorization, okay. Okay, now here we can see a Q which is equal to we take 0, 0, 2, 5, okay, 0, 0, 2, 5. So for option number Q, I written Q as a 0025 and LU, it has a LU decomposition or not. So at initially I consider that Q has a LU decomposition. Okay, and LU I taken as a previously that I consider here BC plus D. Okay, 0025. Now here we can compare the value. B got the 0, C got the 0, BC which is equal to 2. Okay, so 0 which is equal to 2 possible. B is 0, C is 0. So can we say that 0 is equal to 2? Okay, so that means there is no any possible outcome here. Okay, so we cannot define this quantity 0 which is equal to 2. Okay, so this is the quantity which gives our Q matrix do not have LU factorization. Why LU factorization not possible? Because 0 which is equal to 2 never possible. Okay, why 0 is equal to? Because BC which is equal to 2 is there, but already B is 0, C 0. So BC which is equal to 0 into 0, 0. So 0 which is not never equal to 2. Okay, 0 never equal to 2. That's why LU factorization never possible. Okay, it is never possible LU factorization because of this. Okay, so very easy calculations are these. Just we can answer our option orally. Okay, and very easily. Now here we can see the option Q. It says that 0025 has no LU factorization because we cannot consider at 0 which is equal to 2. Okay, so our option number Q which is a true, option number P which is a true. Okay, so option P and option Q both are true. So if you wanted to see the complete solution of my example as I did it here, so you may check it into my notebook here. Okay, so might be you will get the solutions are different than my explanation, but it is okay. So we have to take the example, counter example that can satisfy our properties. Okay, so here we can see so it says that option number P which is a true. Now let's check for option number Q. So here in option number Q, I written our matrix Q and compare with the other LU matrix. Okay, so I got the B0, D0, AB is equal to 2. Okay, so if a B0, then A which is equal to infinitely many choice, but has no LU factorization. Okay, so AD plus C is equal to 5. Okay, so P and Q both statement true. I hope you all have understood my today's example, which is completely based on LU factorization. Okay, question is from linear algebra and quite easy question. Nothing is difficult here on it. So even if you found anything difficult, let me know in comment section. I will come up with some other videos. So thank you everyone. Thank you for my today's lecture.